We will discuss Newton's gravitational law. Sometimes examiners say, state the Newton's gravitational law. Newton's gravitational law is actually the attraction, force of attraction between 2 point masses. One is this mass of m1 and other one is this mass m2. Actually, point masses means if the diameter of this is d1, if the diameter of this is d2, then point masses means the distance between them, this is very much greater than their diameter d1 or very much greater than d2. Means they are not comparable. The size of their these diameters or length of these diameters or length is very much less than the distance between their centers. Always in this chapter we will take R is the distance between center to center. R is always the distance between center to center. So actually another thing is they both will be attracting in such a way in order to obey the third law of motion. If this is the force F, this will be the force F. They will be directed in a line. They must be directed in a line from center to center, and they must be equal in magnitude. So length must be same. This may be small. Length must be same. See, there are a few things when you draw this. This length must be same. Suppose this is 1 centimeter, then this should also be 1 centimeter. They must be in opposite direction. This direction here, this direction here, and they must be in a straight line passing through the center of also that are passing. This actually this is the condition when the Newton's third law is to be made. So actually it doesn't matter whether this body is big and this is small. They will be attracting by the same force each other. Suppose Sun and Earth will be attracting by the same force. It doesn't matter whether the size of the Earth is small or size of the Sun is bigger. It doesn't matter, but acceleration of the Sun will be different and acceleration of the Earth will be different. So let us see how this Newton's gravitational law is stated. Nowadays, very simple. You should write, it is stated that F is equal to G m1 m2 upon r square, and then explain. Then explain F is the force of attraction. Gravitational force is always attractive in nature. G is universal gravitational constant. Its value is fixed. Its value is up to two significant figures, 6.67 into 10 power minus 11. Its unit is Newton meter square per kilogram square kg power minus. So you can find its unit by just writing G is equal to Fr square upon m1 m2. So this is Newton into meter square upon kg square, or Newton meter square and kg power minus 2 is the unit. Then m1 and m2 are two masses. R is the distance between centers of the bodies. And now you have to explain this m1 and m2 are point masses. You will say here diameter d1 is very much less than r1, and diameter d2 is very less than r, where d1 and d2 are diameters of the two masses. It means this law is valid only for point masses. Where I can say F is equal to G m1 m2 upon r square, then just explain what's F. F is the force of attraction. It will be same for both bodies irrespective of the size. For example, suppose this body is one bigger one, this body is smaller one. This body is attracting it by 50 Newton, suppose. Then this will be also attracted by 50 Newton. This force is the bigger force, the body of the bigger force, and this force the force of the smaller force. But they are always exert the same force, gravitational force upon each other. This is you first say F is equal to G m1 m2 upon r square. This is Newton's gravitational law. F is force of attraction. G is universal gravitational constant, or 6.67 10 power minus 11 Newton meter square per kilogram square. m1, m2 are the two masses. R is the distance between centers of the two bodies. Always in this chapter, a few things. First of all, I will take M as the source body, capital M, source body, due to which gravitational field exists, and then R always gravitational field exists. R will always be from center of one body to center of the other. R is the distance from center of one body to center of the other, and mass of the earth will always be 6 into 10 power 24 kg. I will take this. Value of G will be 9.81 newtons per kg, small g, and capital G's value will be fixed 6.67 10 power minus 11 Newton meter square per kilogram square, and radius of earth will also be fixed 6.4 in 10 power 6 meters. These will be the few values which will be taken throughout this common. But R is the distance between two centers, not from surface. It's the just distance between two centers. What I will be taking for my lectures, and I will take always capital M when it is when for the source body due to which the gravitational field will exist. Now I can state this law in words also. What are the words form for this law? I can say, I'll say statement is force of attraction between two bodies, between two point masses, I will write, between two point masses. This is very much essential, this part is directly proportional to product of the masses and inversely proportional to distance between their centers. This is the law in words. I can say, suppose F varies as m1 m2 upon r square, where this m1, suppose m1 is this mass, m2 is this mass, and distance between their centers is r. Both are attracting each other with a force F. This must be directed towards from the center, both cases. So, and I will say F is equal to constant, G is equal to m1 m2 upon r square. This capital G is the universal gravitational constant whose value is same everywhere in the universe. By using this law, I can always calculate the force of attraction between two bodies. Suppose if this is Sun has a mass of suppose 2 into 10 power 30 kg. I'm writing 2.0 10 power 30 kg. So I want answers in two significant figures. And this 6.0 into 10 power 24 kg is the mass of the earth, and the distance is not suppose, but it is actually 1.50 into 10 power 11 meters. I want to find the force between these. In previous lecture, I found that the gravitational force from the centripetal force, gravitational force of pull is 3.6 into 10 power 22 Newton between the earth and the sun, which we calculated by using the centripetal force and those concepts. But I will again calculate by these values. These are the constants, which are constant, fixed constant. I will see almost this value comes. So if F is equal to G is 6.67 into 10 power minus 11, mass of sun is 2 into 10 power 30, mass of earth is 6 into 10 power 24 upon square of the distance is 1.50 into 10 power 11 whole square. And if I want to calculate it exactly, I'm just calculating, it is 6.67 exponential minus 11 into 2 exponential 30 into 6 exponential 24 divided by 1.50 exponential 11 and square. So this is coming out to be 3.557 into 10 power 22 Newton, which is almost equal to 3.6 into 10 power 20 Newton in two significant figures. So we saw that while using this formula of Newton's gravitational law, our results come same, which is due to the centripetal force and other thing. I used in the previous lecture. So this is the Newton's gravitational law, but I will advise you, when it is said, state Newton's gravitational law, just state in this way: F is equal to G m1 m2 upon r square, and then explain the significance of all these 5 symbols. F is the force of attraction between two bodies, G is universal gravitational constant, m1 and m2 are 2 point masses, or masses are the distance between their centers, and then explain the point mass. This distance between this r is much greater than the d1 and d2, which are the diameters of two bodies.